quadratic surfaces can be classified as to whether the coefficients of the x squared, the y squared, and the z squared are relatively positive or negative. You can get ellipses or hyperbolas or parabolas in the planes parallel to each of the coordinate planes and in the slices parallel to each of the coordinate planes. Now, and you really need to look at your text for good pictures of those surfaces, but you should have an idea now where those pictures come from, and there are plenty of online resources that also do a good job. You should understand the basic principles of constructing these surfaces from what we've discussed already. Now, just to be complete, more general quadratic surfaces, the equation ax squared plus bx plus cy squared plus dy plus etc., provided that a, c, and e, the coefficients of x squared, y squared, and z squared, are not zero, can be put into the form ax minus x naught squared plus c times y minus y naught squared plus e times z minus z naught squared plus h equals 0. We do this simply by completing the square on the x's, completing the square on the y's, and completing the square on the z's. And whatever we have to add to complete each square sums up to a number that has to be subtracted from g to get the number h. And if you're familiar and have reviewed the process of completing the square, it's not difficult to see how we get from this form to this form. Now, whether you see that or not, once we have the equation excuse me, in this form, we can do a change of coordinates, and we can let x prime equal x minus x naught squared, equals x minus x naught, y prime equals y minus y naught, z prime equals z minus z naught. And with that change of variables, of that transformation, the equation becomes ax prime squared plus py prime squared plus cz prime squared plus h equals 0, which is just a quadratic surface in x prime, y prime, and z prime. Now, geometrically, that simply corresponds to taking the x, y, z coordinate system and taking the origin and translating it over to the point x naught, y naught, z naught. That's going to be the 0, 0, 0 point of our new coordinate system, so we can draw an auxiliary x prime, y prime, z prime set of axes, and we can proceed to construct this quadratic surface. Let's move that over a little bit so we can see the whole thing. We can proceed to construct this quadratic surface on this set of axes, and we'll be able to, if we can get a good sketch of it, all we've done is we've sketched a quadratic surface with elliptical or hyperbolic or parabolic cross sections here and shown it in relation to the origin of our original x, y, z coordinate system where it's been transformed. You also know that by replacing x by x minus x naught, y by y minus y naught, z by z minus z naught, we do translate a graph, x naught units in the x direction, y naught units in the y direction, z naught units in the z direction, and that's completely consistent with this picture.